Angles of elevation and depression. Angles of elevation and depression, also known as angles of inclination and declination, are used in practical applications of trig. An angle of elevation is the measure of the angle from the horizon up, and the angle of depression is the measure of the angle from the horizon down. So in this drawing, I'm going to label the horizons. There are many horizons with respect to various different objects. From the biker, the horizon up is the angle of elevation. From the balloonist, the horizon down is the angle of depression. So let's describe the relationship of all horizontal lines. Well, all horizontal lines are parallel. So I can label this in my drawing, showing my arrows that indicate parallel lines. So I've labeled that. If the angle of elevation from the biker to the hot air balloon is 35, what is the angle of depression from the hot air balloon to the biker? Well, let's label this 35. Well, the angle would be 35 because we know that these horizontal lines are parallel and alternate interior angles with parallel lines are congruent. So let's label the vertical line here showing the height of the balloon and the right angles that it makes with horizontal lines. Number 5, if the biker at eye level is 4 feet tall and the hot air balloon is 254 feet off the ground, what is the horizontal distance x from the biker to the hot air balloon? Well, we know if we take 254 and subtract 4, it gives us a distance to the horizons, which is 250 feet. So now I'm going to redraw this triangle. We've got a right triangle with a 35-degree angle. The opposite side is 250 feet, and the adjacent side is x. So I can use SOHCAHTOA, my trig functions, in order to solve for the unknown side. So since we know the opposite leg and we're looking for the adjacent leg, why don't we use tangent? Because tangent equals opposite over adjacent. So tangent 35 equals 250 over x. I need to multiply x to both sides. I get x in the numerator on the left. Now I need to undo multiply tangent 35, so I'll divide it to both sides. Make sure in your calculator you're in degrees, not radians. So I need to say x equals 250 divided by tangent 35. I get 357.0 feet. Okay, so I'm going to label that in my drawing, 357 feet. Number 6, what would the distance be line of sight of the biker and the hot air balloon? Okay, so this problem we're looking for the line of sight, which ends up being the hypotenuse of our triangle, looking directly from the biker and the balloon. So we know 35 degrees is our angle, 250 feet is our opposite leg, and 357 is our adjacent. We could use SOHCAHTOA or the Pythagorean theorem. Let's use sine of the angle equals opposite over hypotenuse. So that will be sine 35 degrees equals 250 over c. We can multiply c to both sides to get it in the numerator. And then now we need to undo multiply sine 35 by dividing it to both sides. Make sure you're in degrees. And we get c equals 435.9 feet. That is our hypotenuse. And we can label that in our drawing. The distance between the eye of the biker and the eye of the balloonist is 435.9 feet. And we're done.